periods, while finding the periods of the periodic function, this point is very, very important. Already we discussed 2 points. Next, third point is very, very important. That is no. If the periods of two functions, that is f of x and g of x. If the periods of the two functions, that is f of x and g of x, is some mp and mp comma np respectively. Observe here, the period of f of x is clearly mp and the period of g of x is clearly np. So, if the periods of f of x and g of x is mp and np respectively, here and comma m comma nr positive integers, m comma nr positive integers, and clearly f of x plus alpha is not equals to g of x. F of x plus alpha is not at all equals to g of x, and g of x plus alpha is not equals to f of x. G of x plus alpha is not equals to f of x for any alpha belongs to R. For any alpha belongs to R, then the period of f of x plus or minus g of x, then the period of f of x plus or minus, that means two functions here, their sum or their difference, and f of x by f of x by g of x, that means the quotient of two functions, that is f of x by g of x. The period of f of x plus or minus g of x, or f of x by g of x clearly is some k times of t, that is some k times of t, where k is equals, what is the value of k means? K is equals to LCM of clearly m comma LCM of m comma. Very important point. Observe here. Very important point. If the periods of the two functions is given, that is clearly mp or anything, mp and np. The periods of the two functions, is mp and np is given. What is the period of the function f of x plus or minus g of x, or f of x by g of x, is clearly kt. Kt means where k is the LCM of m and n. Where k is the LCM of least common multiple of m and n. Observe once again. The periods of two functions is given. The periods of two functions is f of x and g of x. F of x and g of x is clearly mp and np. Any constant, that is period of f of x is clearly m, that is period of f, that is mp, and period of g of x is clearly n. Period of f of x is m, period of g of x is m, that is period is m. Period is m. This is f of x period is m and g of x period is m. Respectively, m and n are positive integers. M and n are positive integers. Or mp and n. That is, m and n are positive integers. They satisfy one condition, that is where f of x plus alpha is not equals to g of x. F of x, if any belongs to alpha, that is alpha is belongs to any real number, f of x plus alpha is not at all equals to g of x. That means this function is not equals to this function. And g of x plus alpha is not equals to f of x. G of x plus alpha is not equals to f of x. For any alpha belongs to R, then the period of sum of two functions or difference of two functions, that is f of x plus or minus g of x. F of x plus or minus g of x. F of x plus or minus g of x. Or f of x by g of x. F of x by g of x is clearly k. That is k times of t, kp. What is the value of k means clearly k is the LCM of m and n. LCM of m and n. Let us discuss one example here. Observe here. An example. To understand this concept, let us discuss one more example here. So, the period of, find the period of sin 3x plus 2 plus tan 5x. What is the period? Find the period of sin 3x plus 2 plus tan 5x. This is f of x, this is g of x. This is f of x, this is g of x. First of all, we find the period of this one and period of this one. The LCM is clearly the period of f of sin f of x plus g of x. So observe here, solution. They gave sin 3x plus 2 plus tan 5x. Sin 3x plus 2 plus tan 5x. Already we know that the period of sin ax plus b is equals to, the period of sin ax plus b is equals to how much? 2 pi by mod e. 2 pi by mod e. The period of sin ax plus b or sin ax, the constant is there or is present or absent, not at all is important. The coefficient of x is very, very important. So sin ax is 2 pi by mod e or sin ax plus b is 2 pi by mod e. So sin 3x plus 2 period is clearly is sin 3x plus 2 period is clearly how much? 2 pi by mod e. That means 2 pi by mod e is nothing but plus 3. 2 pi by plus 3. The period of tan 5x period is equals to period of tan 5x. We know that tan ax plus b. Tan ax plus b is equals to, clearly period of tan ax plus b is clearly pi by mod. Pi by mod. Tan ax period is pi by mod. Or tan ax plus b period pi by mod. If b is present or absent, not important. We want the coefficient of x. So tan ax plus b is equals to pi by modulus of x. So clearly, else period is pi by mod e, that is mod 5. Clearly, we get plus 1. So f of x, observe here, f of x and g of x. F of x and g of x are two functions, and periods is clearly mp. This is m, and period of g of x is mp. This is another function, that is n. Respectively, and m and n are any positive integers, and clearly f of x plus sin x plus alpha or sin 3x plus 2 30 degrees is not equal to any alpha. Any alpha is belongs to, clearly sin x plus 2 plus anything alpha is not at all tan 5x, so not equals to for any alpha belongs to R. Then the period of f of x plus or minus g of x. F of x plus or minus g of x. F of x, that is sin 3x plus 2 plus tan 5x. Sin 3x plus 2 plus tan 5x. Value f of x plus or minus g of x is clearly kp. Clearly kp. Therefore the period is period of period of sin 3x plus 2 plus tan 5x is clearly kp. Kp is what? LCM of 2 pi by 3 and pi by 5. 2 pi by 3 and pi by 5. LCM of 2 pi by 3 and pi by 5. So the period of this function is, period of sin 3x plus 2 is 2 pi by 3. Clearly period of sin 3x plus 2 is how much? 2 pi by 3. Period of tan 5x is clearly pi by 5. We want f of x plus g of x. F of x plus g of x. That means sin 3x plus 2 plus tan 5x. Sin 3x plus 2 plus tan 5x is clearly k. K is nothing but LCM of m and n. So the period of sin 3x plus 2 plus tan 5x is LCM of m and n. LCM of m and n. So LCM of m and n. So LCM of m and n. We know that LCM of fractions is equals to LCM of fractions is equals to LCM of numerators by HCF of denominators. HCF of denominators. LCM of the fractions is equals to LCM of numerators by HCF of the denominator. Highest common factor. HCF of the denominators. So very very important formula, that is LCM of the fractions. LCM of the fractions is equals to clearly LCM of numerators by HCF of the denominators. HCF of the denominators. Clearly that is equals to LCM of numerators 2 pi and pi. What is the LCM? 2 pi and pi. Clearly LCM is 2 pi. But 3 and 5. Clearly 3 and 5. HCF is how much? 1. Highest common factor of 3 and 5 is clearly 1. That is equals to here 2 pi. So the period of sin 3x plus 2 plus tan 5x is clearly how much? 2 pi. The period of sin 3x plus 2 plus tan 5x is how much? 2 pi. So very very important point. If the periods of f of x and g of x, clearly mp and np, that is m and n. Period of f of x is m and period of g of x is n. Respectively, m and n are any positive integers. F of x plus alpha is not equal to g of x, and g of x plus alpha is not equal to f of x for any alpha is belongs to r. Then the period of f of x plus or minus g of x. F of x plus or minus g of x. That means the sum of the two functions or the difference of the two functions or two or more functions. Same like this one. So the sum of the two functions or difference of the two functions or the quotient of the two functions is kp. Is how much? K. Where k is the LCM of m and n. LCM of m and n. This is. Let us discuss one more example here. Yes. Let us discuss one more example here. Observe here. One more example. Find the period of that is 5 cos 3x plus 5 cos 3x plus 5 cos 3x plus 3 tan 3x. Find the period of 5 cos 3x plus 3 tan 3x. Find the period of 5 cos 3x plus 3 tan 3x. So solution of the here. Given function is clearly 5 cos 3x plus 3 tan 5 cos 3x plus 3 tan 3x. We know that the period of cos ax plus b is clearly 2 pi by mod a. The period of tan ax plus b is clearly pi by. The period of cos x plus b is 2 pi by mod a, and the period of tan ax plus b is pi by mod a. Tan ax plus b is pi by mod a. Tan ax also already we discussed pi by mod a. If b is present, the option not at all important. We want that is the coefficient of x, that is 2 pi by mod a. Here also 2 pi by mod a. So observe here, period of 5 times of cos 3x. Period of 5 times of cos 3x. 5 times of cos 3x. 5 times of cos 3x. 5 is not at all important. We want the period of cos 3x. Period of cos 3x. Period of cos 3x is clearly period of cos 3x is 2 pi by mod a. So period of cos 3x is clearly 2 pi by mod a. Mod a means 2 pi by mod 3. Mod 3 means clearly plus 3. 2 pi by. Here also, don't want 3 value, we want tan 3x value. Tan 3x value. So what is the period of tan 3x? Period. Clearly, tan ax. Tan ax is pi by mod a. So tan ax is pi by mod a. So clearly, pi by mod a is nothing but pi by. We want the period of, therefore, the period of given function is LCM of is equals to LCM of 2 pi by 3 and pi. Therefore, we want f of x plus g of x is clearly k is the LCM of m and n. K is the LCM of m and n. So LCM of 2 pi by 3 and pi by 3. We want 2 pi by 3 and pi by 3. LCM of. So clearly, LCM of the fractions is equal to already we discussed formula, that is LCM of fractions. LCM of the fractions is equals to LCM of the fractions is equals to LCM of numerators by HCF of denominators. LCM of numerators by HCF of the denominators. So LCM of numerators, that is 2 pi and pi. What is the LCM? 2 pi and pi is clearly 2 pi by. What is the HCF? HCF of 3 and 3. Clearly HCF of highest common factor of 3 and 3 is nothing but 3 more. Therefore period is the period of 5 cos 3x plus 3 tan 3x is clearly 2 pi by 3. The period is how much? 2 pi. That is. In this periodicity, some standard results is there. Some standard results. Standard results. First one. Clearly, the periods of mod sin x. Periods of mod sin x is clearly modulus of sin x. Periods of mod sin x is how much means clearly. Period of sin x is 2 pi. But period of modulus of sin x is how much? Pi. Period of modulus of sin x is how much? Pi. We want positive values. So period is pi. Already we know that is. And modulus of cos x is, and modulus of cosecant x, and modulus of secant x, and modulus of tan x, and modulus of cot x. Periods are clearly pi 1. So modulus of cos x, period how much? Pi 1. Modulus of cosecant x, period how much? Pi. Modulus of secant x, also pi. Modulus of tan x, also pi. Modulus of cot x also. Modulus of cot x also. Period how much? Periods are pi 1. Next, second point. modulus of sin x plus modulus of cos x. Modulus of sin x plus modulus of sin x plus modulus of cos x period is clearly pi by 2. Modulus of sin x plus modulus of cos x period is how much? Pi by 2. In that only, modulus of tan x plus modulus of cot x period is also pi by 2. Period how much? Pi by 2. Next, third one. Modulus of sin x plus cos x. Modulus of sin x plus cos x. Or modulus of sin x minus cos x. Modulus of sin x plus cos x. Or modulus of sin x minus cos x. Period is clearly pi. Modulus of sin x plus cos x period is pi. Modulus of sin x minus cos x is also pi. Next, fourth point. Modulus of tan x plus cot x. Modulus of tan x plus cot x period is pi by 2. And modulus of tan x minus cot x is also periods is clearly pi by 2. So modulus of sin x plus cos x period is how much? Pi. Modulus of sin x minus cos x period also pi. So modulus of tan x plus cot x is pi by 2. Modulus of tan x minus cot x is also pi by 2. Next, fifth point. Sin power mx period is if m is even, sin power mx, if m is even, that is sin square, sin power 4, sin power 6, sin power 8, period is, if m is even, clearly, if m is even, so period is clearly pi. Period is pi. If m is odd, period is clearly 2 pi. M is odd means sin x, period is 2 pi. Sin cube x, period is 2 pi. Sin power 5x, period is 2 pi. Sin power 7x, period is 2 pi. So very important this is. Sin power mx, period we want. If m is even, that means sin square x, sin power 4x, sin power 6x, sin power 8x, and so on. Period is how much? Pi. And if m is odd, then the period is how much? 2 pi. Next, sixth one. Cos power mx, period. If m is even, period is pi. Cos square x, period is pi. Cos power 4x, period is pi. Cos power 6x, period is pi. If m is odd, period is how much? 2 pi. If cos power mx, if m is even, period is pi. If m is odd, period is 2 pi. So standard results. So m is even, we get, that means cos power x period, how much? Cos power x period clearly pi. Cos power 4x, pi. Cos power 8x, pi. Cos power 6x, pi. Cos power 10x, period is clearly pi. Cos x, 2 pi. Cos cube x, 2 pi. Cos power 5x, 2 pi. Cos power 7x, period is also 2 pi. So if m is odd, then the period is clearly 2 pi. If m is even, then period is pi. Next, seventh one, that is a sin power mx plus b cos power mx. We want period. A times of, that is f of x is equals to, that is f of x is equals to given function. This is f of x is equals to a times of sin power mx plus b times of cos power mx. want period means here they have three conditions, that is three conditions is there. Three conditions. First condition, first case, if M and N are even, first condition, if M, comma N are even. If M comma N are even, that means this M and N both are even. M and N are even, and the coefficient of A sin, that is B cos, this coefficients A and B are equal, comma A and B are equal. That means 5 sin power 4x plus 5 cos power 8x is the means. That means A is equals to B. A and B are equal. That means A is equals to B. And M and N are equal. M and N are even numbers. Observe here. 5 times of A is equals to B means if you take A is equals to 5 times of sin power, take 4x. M and N are even. 5 times of sin power 4x plus 5 times of cos power 8x. 5 times of cos power 8x. Here 6 and 4 and 8 are both are even. And A is equals to B. What is the period means clearly? Here the period is pi by 2. Equal, then the period of f of x, then the period of f of x is clearly, this is f of x, this is f of x is clearly pi by 2. F of x is clearly pi by 2. Next, second condition, if M comma N are even numbers, or both are even, M and N are even, and A is not equals to B. A and A is not equals to, A is not equals to B. A is not equals to B. Then the period of f of x is, then the period of f of x is clearly, how much is clearly, that is, that means M and N are even numbers, that is 4 and take 4 and 6. So 2 sin power 4x plus 3 cos power 8x. 2 sin power 4x plus 3 cos power 8x. M and N are even. A is not equal to here, take 2 and B value 3. What is the period? What is the period? Means clearly the period is nothing but 5. The period is nothing but how much? Twice. Next, third condition. If M and N are odd, if M comma N are odd, and if A is equals to B or A is not equals to B, not important, but is M and N are odd, and A is equals to B, or A is different from B, A is same as B or A is different from B, then the period is, clearly 2 pi. Is clearly 2 pi. Very, very important. Observe here while finding the period. The standard points are very, very important. That is modulus of sin x. The period of modulus of sin x clearly pi. Modulus of cos x pi. Modulus of tan x pi. Modulus of secant x pi only. Modulus of cot x pi only. Modulus of cosecant x also. Period of x pi only. So the period of modulus of sin x plus modulus of cos x. Modulus of sin x plus modulus of cos x. The period is clearly pi by 2. Modulus of sin x plus modulus of cos x is how much? Pi by 2. So modulus of tan x plus modulus of cot x. Modulus of tan x plus modulus of cot x is clearly. Period is how much? Pi by 2. And modulus of sin x plus cos x. Modulus of sin x plus cos x. Or modulus of sin x minus cos x. Period is pi. Period is how much? Pi. Next, modulus of tan x plus cot x. Modulus of tan x plus cot x. Or modulus Period is clearly pi by 2. Period is how much? Pi by 2. Next, sine power mx. Sine power mx. Period is, if m is even, period is pi. If m is odd, period is 2 pi. Cos power mx. Period is, if m is even, pi. If m is odd, 2 pi. Next one, if f of x, they gave the function f of x is of a sin power mx plus b cos power mx. A sin power mx plus b cos power mx. If m and n are both even numbers and a is equals to b, that is a and b are equal means that is a is equals to b, then the period of the given function is clearly pi by 2. Then the period of the given function is how much? Pi by 2. And m and n are even, but a is not equals to b. A is not equals to b. That means a is different from b. A is not equals to b. Then the period is clearly how much? Pi. Then the period is pi. Next, m and n are odd numbers. The a and b value equals to a is equals to b or a is not equals to b. So the period of this function is clearly 2 pi. The period of this function is how much? 2 pi. This is very, very important standard business. Next, yes, periodicity is completed. What is the topic? That is periodicity and extreme values. Now we find extreme values of trigonometric functions. Extreme values. Extreme values of trigonometric functions. Extreme values of trigonometric functions. Extreme values of trigonometric functions. Periodicity completed. Next, extreme values. Extreme values. Already we know that. Is theta is belongs to R. We know that theta is belongs to R. The sine function is sine theta. Sine theta always less than or equals to minus 1 and minus 1 is less than or equals to sine theta is less than or equals to plus 1. So we know that for any theta belongs to R. For theta is belongs to any real number. Theta is belongs to any real number. Sine theta is always lies between minus 1 and plus 1. The sine theta is always lies between minus 1 and plus 1. Also we know that sin pi by 2, that is sin 90 value. Clearly sin pi by 2 is equals to how much? 1. Sin pi by 2 is equals to 1 and sin minus pi by 2. Sin minus pi by 2 is clearly minus. Sin pi by 2 is minus pi by 2 is equals to how much? Sin 90 is 1, sin minus 90 is equal to how much? Therefore, the range of the given function is the range of the given function is clearly closed interval minus 1 comma plus 1. Closed interval minus 1 comma plus 1. Closed interval means included minus 1 and plus 1. Included minus 1 and plus 1 and in between the numbers. So, in between minus 1 and plus 1, minus 1, in between minus 1 and plus 1 and included minus 1 and plus 1. That is closed interval. So, the range of the sine function is clearly minus 1. That means the maximum value of sine theta. Maximum value of sine theta is how much? 1. The maximum value of sine theta is 1. The maximum value of sine theta is how much? 1. And the minimum value of sine theta is also, sine theta is minimum value maximum value 1 and minimum value minus 1, and the sign to the range is line 1. The sign to the range is closed interval minus 1 to plus 1. That means included minus 1 and plus 1 in between the minus 1 and 10. All the values of minus in between minus 1 and plus 1. So that's why the maximum value of sin theta is 1 and the minimum value of sin theta is minus 1. So the maximum values and minimum value, the maximum value and the minimum value of the given function is nothing but extreme values of the trigonometric functions. The maximum and the minimum values of the given function is the maximum and minimum values. The maximum and minimum values of the maximum and minimum values of the trigonometric function is called extreme values. The maximum value and minimum value, or the minimum value and the maximum value of the trigonometric functions are called extreme values of the trigonometric functions. Extreme values of the trigonometric functions. So the maximum and minimum values of trigonometric functions. The maximum and minimum values of trigonometric functions are called extreme values of trigonometric functions. Trigonometric functions. Observe here. Already we know that for any theta belongs to R, theta is any real number, sin theta value, already we know that sin theta value is always lies between minus 1 and plus 1. Always sin value, sin range is always lies between minus 1 and plus 1 and included minus 1 and plus 1. Included minus 1 and plus 1. Included minus 1 and plus 1. That is the sin range. Already we know that. Theta belongs for any theta belongs to R. The value of sin theta is always lies between minus 1 and plus 1, included minus 1 and plus 1. So minus 1 is less than or equal to sin theta is less than or equal to 1. That means sin 90, that is sin pi by 2 is clearly plus 1 and sin minus 90, minus pi by 2 is clearly minus 1. So the range of the sin function is closed interval minus 1 to plus 1. Closed interval minus 1 to plus 1. That closed interval meaning what? Included both minus 1 and plus 1. Included both minus 1 and plus 1. So observe here minimum value is minus 1, maximum value is plus 1. Minimum value of the sin theta is minus 1, maximum value of sin theta is how much? Plus 1. Minimum value of the sin theta is minus 1 and the maximum value of the sin theta is plus 1. These minimum and maximum values of the trigonometric functions, these minimum values and maximum values, these minimum and maximum values of the given trigonometric function is called extreme values of the trigonometric functions. Extreme values, extremities means maximum and minimum value. Extremities, maximum and minimum value. Maximum and minimum value is nothing but extreme values of the trigonometric functions. Extremities values of the trigonometric functions. Extreme values of the trigonometric functions. So, also we know that cos theta also, for any theta belongs to R, for theta is belongs to R, how do we know that? For any theta belongs to R, cos theta is also lies between is minus 1 is less than or equals to cos theta is less than or equals to plus 1. Theta is belongs to any real number. Theta is belongs to any real number. So cos value always lies between minus 1 and plus 1. Theta is belongs to any real number. No problem. Theta is belongs to any real number. Cos value also lies between minus 1 and plus 1. Minus 1 and plus 1 and included minus 1 and plus 1 also. Therefore, the range of cos theta is equal to closed interval minus 1 comma plus 1. Closed interval minus 1 comma plus 1. The range of the cos theta is equal to closed interval minus 1 comma plus 1. Minus 1 comma plus 1. Here the minimum value. Minimum value is equals to how much? Minimum value of cos theta is equals to how much? -1. Minimum value of cos theta is equals to -1. Maximum value, the maximum value is equals to value of cos theta is equals to +1. Minimum value of cos theta is how much? -1, and the maximum value of the cos theta is equals to +1. So the extremities, that is extreme values of the cos theta is nothing but -1 and +1. Extreme values is nothing but maximum extremities. Extremities means last values, that is minimum and maximum values. Extremities values is nothing but extremities, extreme values. Extreme values is nothing but minimum value and maximum values for what? Extreme value. So cos theta minimum value is -1 and maximum value is how much? +1. So cos theta minimum value is -1, maximum value +1. So extreme values of cos theta is -1, +1. Extreme values of cos theta. Extreme values of cos theta is how much? -1, +1. -1, +1 is the extreme values of the cos theta. Same sin theta also. The extreme values of sin theta is also -1, +1. If sin theta and cos theta are included, that means it is in the form of a sin x plus b cos x plus c. How to find the extreme values? That means two functions are involved. Sin theta extreme values is clearly -1 and +1. Cos theta extreme values is -1 and +1. If their combination, if some are different, how to find the extreme values? Let us discuss one theorem here. How to find the, if involving of two trigonometric functions, that is sin x plus cos x. How to find the extreme values? How to find the extreme values? Let us discuss one theorem here. Theorem, that is theorem. Theorem. If a comma b comma c is belongs to all the real numbers, if a b c belongs to R, and clearly a square plus b square value is not equals to 0. A b c belongs to R, and clearly a square plus b square value. A square plus b square value is not equals to 0. A square plus b square value is not equals to 0. Then the minimum and maximum value of the function, that is then the maximum and minimum, then the maximum and minimum value of the function, then the maximum and minimum values of the function, that is ABC belongs to R and a square plus b square. A square plus b square clearly not equals to 0, then the maximum and minimum values of the function, that is a sin x plus b cos x plus c. A sin x plus b cos x plus c. What is the function? A sin x plus b cos x plus c is clearly c plus square root of a square plus b square and c minus square root of a square plus b square over all the real numbers. Observe here, theorem is if a b c belongs to R, belongs to R, and clearly a square plus b square value. A square plus b square value is not equals to 0. A square plus b square value is not equals to 0. Then the maximum and minimum value of the function. Maximum and minimum value of the function, that is given function is a sin x plus b cos x, or a cos x plus b sin x. A cos x plus b sin x plus c is c plus square root of a square plus b square, c plus square root of a square plus b square, and c minus square root of a square plus b square. That is maximum value is c plus square root of a square plus b square. Maximum value how much? C plus square root of a square plus b square, and the minimum value is c minus square root of a square plus b square. So total any number, any real number, that is proof. Given function f of x is equals what? A sin x plus b cos x plus c. Given function f of x is equals to a sin x plus b cos x plus c. A sin x plus b cos x plus c. Put a is equals to R cos theta put A is equals to R cos theta and B is equals to R sin theta. Put A is equals to R cos theta and B is equals to R sin theta. What is the value of R? By using of this one, here observe here. A square is equals to R square cos square theta and B square on both sides. We get B square is equals to R square sin square theta. If you add this, A square plus B square is equals to R square cos square theta plus R square sin square theta. That is A square plus B square is equals to R square into sin square theta plus cos square theta. That is A square plus B square is equals to clearly sin square theta plus cos square theta value 1. So we get R square. So we want R value. R is nothing but square root of A square plus B square. R is nothing but how much? Square root of A square plus B square is the value of R. What is the value of R means? R here. Here in the place of A, put R cos theta. In the place of B, put R is R sin theta. We value how much? R sin theta. If A cos x plus B sin x is there, if A cos x and B sin x is there, means put A is equals to R sin theta, put B is equals to R cos theta. But here A sin x plus B cos x plus C is there. So put the value of R. A is nothing but, what is the value of A is nothing but value, let us assume that A is equals to R cos theta. A is equals to how much? R cos theta. And B is equals to R sin theta. Let us assume that A is equals to R cos theta and B is equals to R sin theta. Observe here. By using of A is equals to R cos theta and B is equals to R sin theta, what is the value of R means eliminate the theta. How to eliminate the theta means square it on both sides. We get A square is equals to R square cos square theta. B square is equals to R square sin square theta. B square is equals to R square sin square theta. If you add the equation 1 and 2, that is A square plus B square. A square plus B square is clearly R square into cos square theta plus R square into sin square theta. If you take R square as common, we get sin square theta plus cos square theta. Already we know that sin square theta plus cos square theta is the identity and value is 1. So we get R square. R value what? R is equal to square root of A square plus B square. What is the value of R? Square root of A square plus B square. Observe here, then f of x equals A sin x plus B cos x plus C. So if you put A value R cos theta, we get R cos theta into sin x, R cos theta into sin x plus B value clearly R sin theta into cos x, R sin theta into cos x plus C. A value R cos theta, put here A value R cos theta and B value clearly R sin theta. In both R cos theta into sin x, R sin theta into cos x, take R as common here. We get here cos theta into sin x plus sin theta into cos x plus C. Observe here, it is in the form of sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B. It is in the form of sin A cos B. Sin A cos B plus cos A sin B. What is the formula of sin A cos B plus cos A sin B? Is nothing but sin A plus B. So R times of, we get here sin A plus B means sin x plus theta. Sin x plus theta plus. Observe here, it is in the form of sin A cos B. Sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B is nothing but sin A plus B. Sin A plus B means sin x plus theta. Sin x plus C. So already we know that R into something, R sin times of x plus theta plus C. So already we know that what is the extreme values of sin theta means clearly extreme values of sin theta minus 1 is less than or equals to sin, that is x plus theta is less than or equals to r. Already we know that the value of sin theta is always lies between minus 1 and plus 1. The sin theta, the extreme values of sin theta is nothing but minus 1 to plus 1. So minus 1 is less than or equals to sin x plus theta is less than or equals to 1. But here r times of sin theta is there, but here we get sin theta only. So both sides multiplied by r, we get minus r less than or equals to r times of sin x plus theta is less than or equals to r. We get r sin x plus theta. R Also plus c is there. Add plus c. Add plus c. We get c minus r is less than or equals to r sin x plus theta is less than or equals to c plus r. So c minus r, here also add plus c here, plus c here is less than or equals to clearly c plus r. So c minus r is less than or equals to r times of sin x plus theta plus c. Observe here, r times of, we get the function that is f of x is equals to, we get the function r times of sin x plus theta plus c, r times of sin x plus theta plus c, r times of sin x plus theta plus c. What is the maximum minimum value? C minus r. What is the maximum value? C plus r. Therefore, by using this one, the minimum value is equals to how much? C minus r. Already we know that r value how much? R is nothing but square root of a square plus b square. So minimum value is c minus square root of a square plus b square. What is the maximum value? Here is c plus r. The maximum value is equals to c plus r. C plus r is nothing but c plus square root of a square plus b square. C plus square root of a square plus b square. The minimum value is c minus square root of a square plus b square. The maximum value is c plus square root of a square plus b square. By using of minimum and maximum, what is the range of the given function? What is the range? Range is equal, therefore, range of f of x is equals to clearly, so range of f of x is equal to closed interval, minimum value here, c minus square root of a square plus b square, comma, c plus square root of a square plus b square is the range of the given function. Observe here, that is very important theorem. Already we know that the extreme values of sin theta. Extreme values of sin theta is clearly minus 1 and plus 1. Extreme values of cos theta minus 1 and plus 1. If they gave sum or difference of the sin and cos, that is a sin x plus b cos x plus c, or a cos x plus b sin x plus c. How to find the extreme values? We have a theorem, that is, if a, b, c are any real number, and clearly a square plus b square value not equals to 0, then the maximum and minimum value of the given function, that is a sin x plus b cos x, plus c is c plus square root of a square plus b square is nothing but maximum value is how much? C plus square root of a square plus b square, and the minimum value is c minus square root of a square plus b square. Maximum value is c plus square root of a square plus b square, and the minimum value is c minus square root of a square plus b square over any values of c, a, b, or any value, all the real values, maximum and minimum value is 6. Let us discuss proof. That is, given function is clearly f of x equals a sin x plus b cos x plus c. Or if they gave a cos x plus b sin x plus c, same answer we get. That is, a sin x plus b cos x plus c, they gave a sin x plus b cos x plus c. If the value of a, substitute a is equals to, let us assume that r cos theta, a is equals to r cos theta, and the value of b equal to r sin theta, then the value of b is equals to r sin theta. A is equals to r cos theta and b is equals to r sin theta. What is the value of r? By using of a and b, eliminating the theta. How to eliminate the theta means squaring on both sides. A square is equals to r square cos theta. A square is equals to r square cos theta. Here also squaring on both sides. B square is equals to r square sin square theta. We get two equations, equation 1 and equation 2. Add 1 and 2, we get a square plus b square is equals to r square cos square theta plus r square sin square theta. If you take r square as common, we get sin square theta plus cos square theta. Already we know that identity, that is sin square theta plus cos square theta is equals to how much? 1. So r square into 1 is nothing but r square. We want r value. If you transpose square, we get square root. R is equals to square root of a square plus b square. R value how much? Square root of a square plus b square. Yes, observe here. Put a is equals to r cos theta in this function. A value clearly r cos theta and sin x plus b value clearly r sin theta into cos x plus c. This is function. If we take r as common here, we get cos theta into sin x plus sin theta into cos x plus c. It is in the form of clearly sin a cos b, sin a cos b plus cos a sin b, sin a cos b plus cos a sin b, sin a cos b plus cos a sin b is nothing but sin a plus b. Sin a plus b means sin x plus theta b. Sin x plus theta. So r times of sin x plus theta plus c is there plus c. So r times of that r into sin x plus theta is nothing but r times of sin x plus theta plus c. We want this range or maximum value. This function is nothing but this function. If you find the maximum value of this function, we get the maximum and minimum value of this function. So we want the maximum and minimum value of this function. Clearly sin function value already we know that the trigonometric function, that is sin function maximum and minimum value clearly minus 1 and plus 1. So sin function is always lies between minus 1 and plus 1, including minus 1 and plus 1. That is minus 1 is less than or equal to sin x plus theta is less than or equal to plus 1. But here function is r times of sin x plus theta plus c is there. So I want to convert this framing, this function framing. So here we get sin x plus theta. Don't have r and c. First of all, multiply by r. We get r into minus 1 minus r less than or equal to r times of sin x plus theta is less than or equal to r into 1 is nothing but r. So we get r sin x plus theta. We get already r. Also we have plus c also. So totally add plus c here in that equation. That is inequalities. So c minus r plus c is minus r plus c. Minus r plus c is nothing but c minus r is less than or equal to r times of sin x plus theta plus c is less than or equal to c plus r. So c minus r is less than or equal to r times of sin x plus theta plus c. We get this function only, r sin x plus theta plus c. R sin x plus theta plus c. We get this function. So here this is called minimum value, this is called maximum value. What is the minimum value here? Where the minimum value of this function is c minus r. Minimum value of this function is c minus r. Already we know that r value how much? Square root of a square plus b square. A square plus b square. So c minus r is nothing but c minus square root of a square plus b square. So minimum value of this function is how much? This function is nothing but this function only. So minimum value of this function is c minus square root of a square plus b square. Square root of a square plus b square. What is the maximum value? Maximum value here c plus r. Maximum value how much? C plus r. So c plus r. So c plus r means r value already we know that r value is square root of a square plus b square. So c plus square root of a square plus b square is the maximum. So c minus square root of a square plus b square is the minimum value, and c plus square root of a square plus b square is the maximum value of this one. If they give a cos x plus b sin x plus c, minimum value is c minus square root of a square plus b square, and the maximum value is c plus square root of a square plus b square. So by using a minimum and maximum, what is the range? Range of this function is clearly closed interval c minus square root of a square plus b square, c minus square root of a square plus b square, comma c plus square root of a square plus b square is the range of the given function. If they gave the tan and cosecant and secant, convert into sin and cos, we get the same process. If they gave the tan x plus 5s, tan x plus secant x like that, compulsory they want extreme values, tan, cot, secant, cosecant, convert into sin and cos, that is converted into this framing, that is a sin x plus b cos x plus c, convert into this framing. That after that we find the maximum value c minus square root of a square plus b square and c plus square root of a square plus b square. Let us discuss small example to understanding. Let us discuss one example here. Example. Find the maximum and minimum value Find the maximum and minimum value of the maximum and minimum value of the function. 3 sin x minus 4 cos x. 3 sin x minus 4 cos x. We want the maximum and minimum value of this function. 3 sin x minus 4 cos x. 3 sin x minus 4 cos x. We want the maximum and minimum value. Given function, clearly solution. Given function f of x is equals to clearly 3 sin x minus 4 cos x. 3 sin x minus 4 cos x. Compare with a sin x plus b cos x plus c. Compare with a sin x plus b cos x plus c. What is the value of a? Clearly a is equals how much? 3. A is equals to 3 and b is equals how much? B is equals to clearly minus 4 and c is equals how much? 0. C is equals how much? 0. A is equals to 3 and b is equals to minus 4 and c value here not that, so c is equals to 0. Compare with a sin x plus b cos x plus c. So we want maximum value first of all. The maximum value is equals to the maximum value is equals to, already we know that the maximum value is equals to maximum value of this function is clearly c plus square root of a square plus b square. Maximum value of the function is equals to what? Formula is what? C plus square root of a square plus b square. C plus square root of a square. What is the value of c? Clearly 0 plus square root of a value here 3 whole square plus b value here minus 4 whole square. So that is equals 0 plus anything. So we get 3 square means 9, 4 square means here 4, 4 square means we get 16. That is equals square root of 16 plus 9, 25. Square root of 25 is equal to 5. So maximum value of this function is how much? 5. And the minimum value, we want minimum value also. The minimum value is clearly is equals to formula what? C minus square root of a square plus b square. C minus square root of a square plus b square. C minus square root of a square plus b square is the minimum value. Find the value. Minimum value. So that is equals to minimum value is equals to C minus 0 minus square root of a square. Here value how much? Here again 3 whole square plus b square minus 4 whole square. That is minus times of square root of 9 plus 16 only. That is equals to minus square root of 25. That is equals to minus 5. What is the minimum value? Is minus 5 and the maximum value is 5. So they ask the question that is the find the maximum and minimum value of the given function a 3 sin x minus 4 cos x. 3 sin x minus 4 cos x. 3 sin x minus 4 cos x combined with a sin x plus b cos x plus c. Here a value clearly 3 and b value clearly minus 4, c value not there, c is equals to 2. Already we know that the maximum and minimum values of a sin x plus b cos x plus c. A sin x plus b cos x plus c is maximum value is c plus square root of a square plus b square and the minimum value is c minus square root of a square plus b square. If you substitute a, b, c value in that one we get plus 5 is the maximum value and minus 5 is the minimum value. They want range of this function means so range of f of x is equals to minimum closed interval minimum value comma maximum value. Closed interval minimum value comma maximum value is the range of the given function. Let us discuss. Observe here. Note one thing. What is the minimum and maximum value of sin x? That is, if sin power even is there, sin x power even is there, then the minimum and maximum value is 0 comma. That is range is how much? Closed interval 0 comma 1. That is minimum is 0, maximum is 1. Sin power even x. That is sin square x, sin power 4x, sin power 8x, sin power 10x. Clearly 0 comma 1. Sin power odd times of x is belongs to clearly minus 1 comma plus 1. So minimum value of sin x is minus 1. Maximum is plus 1. Minimum of sin cube x. Sin cube odd is there with sin cube x. Minimum is minus 1. Maximum is plus 1. Also, cos also the cos power even times of x. Cos power even times of x is equals to, here also cos power even times of x is nothing but this belongs to closed interval 0, 1, closed interval 0, 1. That is cos power x. Minimum is 0, maximum is 1. Cos power 4x. Minimum is 0, maximum is 1. Cos power 6x. Minimum is 0, maximum is 1. So cos power odd times of x is belongs to, minimum is clearly minus 1 and maximum is plus 1. Observe it, very, very important. This is not. This is. So sin power even times of x. Sin power even times of x is nothing but belongs to 0, 1. Minus or minimum value is 0, maximum value is 1. Sin power odd times of x. Odd. That is clearly belongs to minus 1. Minus is minus 1 to plus 1. That is minimum value is minus 1. Sin power odd. That means sin cube. Sin power 5x. Sin power 7x. Minimum is minus 1. Maximum is plus 1. So cos power even x. That is cos power x. Cos power 4x. Cos power 8x. Cos power 10x. Value is 0, 1. Minimum value is 0 and maximum value is plus 1. Cos power odd times of x. That is cos power x. Cos x. Cos 3x, cos power 3x, cos power 7x, cos power 5x, cos power 11x is clearly minimum is minus 1, maximum is plus 1. This is called extreme values of the trigonometric functions. Extreme values of the trigonometric functions. In this chapter, we discuss some more examples, some more problems. Let us discuss some more problems. Yes, periodicity and extreme values we are discussed in the previous video. In this video, let us do some more problems with periodicity and extreme values. First problem is the period of cot x plus 5x plus 9x is. We want the period of this solution. So here cot x plus 5x plus 9x. Clearly, these are like terms. X plus 5x, clearly 6x. 6x plus 9x, we are getting 15x. Already we know that the cot of the period of cot ax plus b is pi by modulus of. The period of cot ax plus b is pi by modulus of. We want, therefore, the period of cot 15x. Cot 15x, clearly here a value 15 is equals to pi by modulus of 15. Pi by modulus of 15. Clearly that is equals to pi by. So we want the period of x plus 5x plus 9x. 9x plus 5x, 14x plus x, clearly 15x, these are like terms. So we want cot 15x period. Already we know that cot ax period is pi by modulus of e. Cot ax period is how much? Pi by modulus of e. So cot 15x, a value here clearly 15. So period is pi by modulus of e. Pi by modulus of 15, clearly pi by 15. Next, second one. Observe here. The period of cot 5 minus 7x by 2. Cot 5 minus 7x by 2. If you separate the denominator, we get here, they gave cot 5 minus 7x by 2. If you separate the denominator, we get here cot 5 by 2 minus 7x by 2. Cot 5 by 2 minus 7x by 2. This can be written as, that is cot minus 7x by 2 plus 5 by 2. Cot minus 7 by 2x minus 7x by 2 plus 5 by 2. Already we know that the period of cot ax plus b. Cot ax plus b is equals to pi by mod a. The period of ax plus b is equal to pi by mod a. Clearly a value here minus 7 by 2. Therefore, the period of cot 5 minus 7x by 2 is equal to pi by, here a value how much? A value clearly minus 7 by 2, modulus of minus 7 by 2. That means modulus of minus 7 by 2 means we get plus 7 by 2. If you remove the modulus, we get positive quantity. Modulus means always gives positive quantity. So, if you write the reciprocal, we get that is 2 pi by 7. Therefore, the period of cot 5 minus 7x by 2 is merely 2 pi by 7. Next problem, observe here. Period of sin x into sin 120 minus x into sin 120 plus x we want. Clearly, solution, they give sin x into sin 120 minus x into sin 120 plus x. It is in the form of sin a minus b into sin a plus b. We know that sin a plus b into sin a minus b is equal to sin square a minus sin square b. Sin a plus b into sin a minus b. Sin a plus b into sin a minus b is equal to sin square a minus sin square b. That means this can be written as sin x into sin a minus b into sin a plus b. That is sin square a minus sin square b. That is sin square 120 degrees minus sin square b is clearly x. Sin square 120 minus sin square x. So sin x into 120. 120 can be written as sin 90 plus 30, clearly 120. So this can be written as sin 90 plus 30 whole square minus sin square x. Sin 90 plus theta. Sin 90 plus theta clearly lies in second quadrant. In the second quadrant, sin is positive and 90 means sin ratio changes to cos ratio. So we get here sin x into sin 90 plus theta clearly, that is cos square is there, so cos square 30 minus sin square x, or cos 30 degrees whole square minus sin square x. That is equals to sin x into cos 30 value. Cos 30 value, how much? Cos 30 is equals to square root of 3 by 2. That is square root of 3 by 2 whole square minus sin square x. That is equals to sin x into root 3 by 2. Square root of 3 by 2 whole square is nothing but 3 by 4 minus sin square x. 3 by 4 minus sin square x. If you do LCM here, we get clearly that is equals to sin x into 3 minus 4 sin square x by 4. If you multiply by sin x, we get here, if you take 1 by 4 as common, we get sin x into 3, that is 3 sin x minus sin x into 4 sin square x, we get 4 sin cube x. So, already we know that 3 sin x minus 4 sin cube x. 3 sin x minus 4 sin cube is nothing but sin 3x, formula is there. So, that is equal to, we get 1 by 4 into sin 3x. 1 by 4 into sin 3x. The period of 1 by 4 into sin 3x is nothing but sin x into this value is equal to this value. So the period of 1 by 4 into sin 3x is nothing but sin x into sin 120 minus x into sin 120. So the period of 1 by 4 times of sin 3x is equal to, how do we know that? Sin ax plus b. Sin ax plus b, the period of sin ax plus b is 2 pi by modulus of a. 2 pi by modulus of a. Here, clearly that is 2 pi by modulus of a value. Clearly here, how much? 3. So, this can be written as that is 2 pi by. So, 1 by 4 times of sin 3x. 1 by 4 times of sin 3x. So, the period of sin ax plus b. Period of sin ax is clearly 2 pi by modulus of a. 2 pi by modulus of a. So 1 by 4th time of sin 3x period is also 2 pi by modulus of 3. That is nothing but 2 pi by 3. Next, fourth problem. Observe here. The period of tan x into tan 2 pi by 3 minus x into tan 2 pi by 3 plus x. So solution clearly this can be written as tan x into tan 2 pi by 3 minus x into tan 2 pi by 3 plus x. Clearly tan a plus b into tan a minus b. We know that tan a plus b into tan a minus b is equal to tan a plus b into tan a minus b is equal to clearly tan square a minus tan square b by tan square a minus tan square b by tan a plus b into tan a minus b. Tan a plus b into tan a minus b is equal to tan square a minus tan square b by 1 minus tan square b into tan square b. That is formula tan a plus b into tan a. Tan a plus b into tan a minus b is tan square a minus tan square b by 1 minus tan square a into tan square b. So substitute here we get tan x into tan square a. Tan square a means clearly 2 pi by 3 minus tan square b means tan square x by 1 minus tan square a means clearly tan square 2 pi by 3 into tan square b means tan square x will get. That is equal. Tan x into 2 pi by 3. 2 pi by 3 means 3 ones are 360 is a 180. 60 into 2 is nothing but 120. So we get here tan square 120 minus tan square x by 1 minus tan square 120 into tan square x. So 2 pi by 3 value clearly 120 degrees. So tan 120 can be written as, observe here, tan 120 can be written as tan 90 plus 30. Tan 90 plus 30 clearly 120. Tan 90 plus theta clearly it is also in second quadrant. In second quadrant tan is have negative sign, so minus cot 30 we get. But here square is there, we get cot square 30. That is square is there. So we get cot square 30. Right here, that is tan x into, that is equals to tan x into tan square 120 can be written as cot square 30. Cot square, that is cot square 30 degrees minus tan square x by, here also 1 minus cot square 30 into tan square x. Tan square 120 value is equals to cot square 30. Tan square 120 value is same as cot square 30. That is equals to, already we know that tan x into cot 30 value. Cot 30 clearly square root of 3. So substitute here square root of 3 whole square minus tan square x by 1 minus square root of 3 whole square into tan square x we get. So clearly square and root get cancelled. That is equal to tan x into 3 we get 3 tan x minus tan cube x by 3 tan x minus tan cube x by 1 minus 3 tan square x. In denominator we get 1 minus clearly 3 tan square x. 3 tan x minus tan cube x by 1 minus 3 tan square x is nothing but tan 3x formula. So we get here tan 3x. The period of tan 3x is same as the period of tan x into tan 2 pi by 3 minus x into tan 2 pi by 3 plus x. Therefore, the period of is equals to, already we know that the period of tan ax plus b or tan ax is clearly pi by modulus of a. So here we get pi by modulus of a means we get modulus of 3. Modulus of 3 means gives us positive quantity, so pi by 3. The period of tan 3x, the period of tan 3x is how much? Pi by 3. This is next.